Okay, hello everyone. Today it is my pleasure to introduce Morgan Klaus Scheuerman. Morgan is a research scientist at Sony AI. His research focuses on the intersection of technical infrastructure and marginalized identities. In particular, Morgan examines how gender and race characteristics are embedded into algorithmic infrastructures and how those permeations influence the entire system. His work has received multiple Best Paper awards and honorable mentions at CHI and CSCW. I'm very excited to hear from Morgan today. Morgan, the floor is yours.
Thank you so much. Yeah, a little awkward. My slide notes are over here, so I'll kind of be staring over here. But thank you all for coming. I'm going to be presenting this work titled Envisioning Identity, the Social Production of Computer Vision Systems. So this is actually work that I did during my dissertation. So prior to Sony AI, this is work I did in information science at University of Colorado Boulder. I think I might have more of an introduction here that I can just skip to. If I can get my slides to move. There we go. So I just want to go over kind of the structure of this talk so people can follow along a little more easily. So I have kind of an about me section I'll probably breeze through. And then I'm going to introduce the problem space that I've been working in, which is how identity is conceptualized in computer vision specifically. And I'll describe a number of studies that I've done focused on identity and computer vision, and then conclude with some potential kind of research directions or broader things that we can think about in this space. So I kind of have this introduction that's a little more about other things that I've worked on as well. So I haven't just focused on identity and computer vision, but I've also looked kind of at issues of moderation and online safety, broader marginalized experiences, whether that's in online communities or with these types of machine learning technologies. And then also at kind of a high level, how values are embedded in machine learning technologies. But for the purposes of this talk, I'm mostly going to focus deeply on how identity is conceptualized in computer vision technologies. And so I'm going to talk about how identity is generally often used as an infrastructure for technology. And so when I say infrastructure here, what I mean is that identity is treated as this kind of underlying truth on which we can build technologies. So these fuzzy and contextual concepts like identity are designed to fit into technical infrastructures. And those designs then impact how we as users or even as targets of these systems can interact with the world. So what do I mean by identity in computer vision? So I want to lay out kind of the background of this problem space I've been working in, starting with identity as this concept. So identity is central to every aspect of our experiences as humans. In particular, visible identities regularly impact our lives and how we view not just other people, but how we view ourselves. So we all experience the visible external features that are associated with identity when we're interacting with the world. And as a result of those interactions, we hold our own affinities with identity. So identity concepts like gender, race, ethnicity, sexuality, religion, nationality, and class are entangling to shape the way that we are relating to ourselves and the way we are relating to other people. And they operate on this broader societal scale. And with this growing momentum of machine learning that's designed to make really consequential decisions about human lives, identity has become an area of major focus and concern. In particular, the domain of computer vision regularly uses subjective identity characteristics in many different ways. Computer vision is often designed to recognize everything from race and gender to even emotion and intelligence. And classifying humans, whether it is for these more explicit identity-based classifications like race and gender, or whether it's for something like facial recognition or gender recognition, always require information about human identity. The way that computer vision models work pretty broadly is that they're fed a lot of data for recognizing certain classifiers. So For example, if a person wants to build something like a gender classifier, these are generally designed to recognize genders like just male versus female. And to train it, machine learning engineers or researchers basically feed it many images of people who've already been annotated or sorted into buckets of male or female, with the goal of then teaching the model to classify male or female for any unknown faces. However, even though computer vision is designed to classify identity characteristics, it actually often fails at doing this. So there's been a ton of literature on identity failures in computer vision, instances where computer vision models are exhibiting discriminatory or biased results on certain groups. For example, a number of scholars have found instances of racial bias, gender bias, and cultural bias in computer vision. And there are some examples of those on the screen if you want to check them out. They're super interesting. And these failures matter because they actually result in real world consequences. So it's not just in the sense, this like isolated model sense, but when those models are deployed in the world, it can actually really impact people's lives. So one might have the inability to access services that are powered by computer vision. For example, a Brooklyn landlord installed facial recognition in rent stabilized apartments, barring tenants who the system did not properly recognize. And when you consider issues of racial and gender bias, who is not being recognized as a tenant becomes another kind of layer of issues on top of that. They might also result in demeaning stereotypes that perpetuate bias and upset people who are interacting with the system. So there's this notorious example now of Google's Photos app automatically tagging photos of Black people's faces in the images as gorillas. And these failures might even result in extremely life-altering material consequences. Like there have been a number of wrongful arrests of Black men in the United States due to police overtrusting their facial recognition systems. In fact, computer vision has also been used to purposely discriminate against minority groups. So Giggle is this women's only app, and the CEO has pretty explicitly stated she's discriminating against trans women trying to access the service. So if somebody doesn't look female enough, they're not allowed to join the social media app. And there's this other kind of like controversial issue that's been touched upon a lot, which is Huawei in China designing computer vision to aid the government in targeting an ethnic minority group, particularly Uyghurs. And because of situations like this, many scholars have rightfully focused on the impacts computer vision has on particular identity groups. And these examples, oh, sorry. Okay, I'll continue. These examples are all problems at the product level, issues that have occurred after a product was created and deployed. So I'll focus on that in this talk, but I also am going to argue that it's not sufficient to only focus on the harm caused by these finalized products. We actually need to focus on how identity is being implemented in these products throughout the development pipeline. So the lesson here is that computer vision regularly attempts to classify aspects of identity, but it often perpetuates harm, particularly against minority groups. But how is identity actually being implemented in computer vision? And can examining how identity is implemented reveal more about the harm computer vision causes and how we can improve it? So just fix computer vision broadly isn't really a useful statement because identity is actually implemented by many actors across a complex development pipeline. And this is just a simple and linear representation of that pipeline, from requirements to conducting annotations to the end product itself. And in this talk, I'm going to demonstrate that identity in this pipeline actually moves from something that could be open and full of opportunity to something that is closed and rigid, and that we should be addressing identity at each stage of this pipeline. So I'm going to go over studies in 3 areas. The first addresses the question, how does race and gender show up in computer vision artifacts currently? I guess currently things have changed quite rapidly in this space, so it always quickly becomes very different for those of us who are working in AI. It moves very quickly. The second attends to values that are implicitly embedded in these artifacts. So how identity in computer vision artifacts are actually showcasing specific human values. And then the final study I'll go over is how worker positionalities actually influence identity values in these systems. So I'll start with the issue of how visible identities are currently represented in computer vision artifacts, particularly data sets and models. Specifically, I'm going to examine race and gender as examples of how identity is represented in these systems. So at a really high level, I'm going to show that gender and racial concepts in these systems are often offensive and inconsistent. Transgender people, particularly trans men, are actually regularly misclassified by gender classification systems, and non-binary people can't be accurately classified at all due to the values that people have embedded into these systems. And so this work kind of covers two papers that I've published that you can check out for more details later on. So given identity is so embedded in these technical systems, have you ever thought about how you might be seen by your technology and what labels make up who you are? So really early on in my work, I had this question, so I decided to check out the kind of things that computer vision models think about me. This was back when I had longer hair. Microsoft's system classified me as happy, 20 years old, and male in this image. And then IBM's, on the other hand, classified me as age 13 to 16 and female, which for me is a misclassification. And you can also see that it tagged me as a cat fancier, which is correct. I have two cats, although I think they left the room. And this is an example of facial classification of gender in both object labeling and in the facial classification. And so gender actually often showed up in object labeling as well. So why was I classified as male in one system and female in another? So the outputs produced by these types of facial analysis systems are premised on their training and evaluation data. So the images we're using to quote unquote teach a system what a subject looks like. And images are often used to train two different computer vision pipelines. The first is facial classification. So you input an image, the model detects a face is present, and it always returns this predefined set of classifications. In this case, the model always returns a gender classification for every face detected in the image. And the second pipeline is object labeling. In this case, you input an image, the model detects relevant objects it's been trained to identify. So in the example of a cat fancier, it's possible that the model saw there was a cat present in the image and it returned labels it associated with that object, the cat. So in one of the studies that I did, I explored kind of the classes and labels used to describe race and gender in different image data sets. So I looked at 92 image data sets, ranging from really large data sets to much smaller kind of toy or academic data sets, and found that there were really vast inconsistencies, particularly for racial categories and methods for determining the race of a person in image data. So some databases employed 3 racial categories like MS Celeb 1 million, which has now been retracted. Meanwhile, others would employ 7. I also found consistently binary categories of gender, although this showed up in many different ways. And in both cases, authors rarely justified their categorical decisions or explained how they labeled the images. How categories were represented also often employed problematic language. So we can see this when we look at the 3 racial categories in MS Celeb 1 million, which actually harken to these obsolete racial categories that were common in the age of colonialism, which I'll touch on a little bit in a bit. And we can also see that PubVig only had 2 gender categories, male and attractive woman, which assigns these stereotypical and sexist beliefs about the importance of appearance to women, but not to men. But how are these categories actually showing up in models, and how often are people being misclassified? So in the second paper in this section, I examined how not only cisgender men and women, but also how trans and non-binary genders were classified in commercial computer vision systems. And so I conducted an evaluation of 5 commercial computer vision services: Amazon, Clarify, IBM, Google, and Microsoft. And I will say that a lot of these services have changed since publishing this paper. A lot of companies have taken a stance against doing gender classification within recent years. But at the time, and possibly still, there wasn't really a data set of diverse genders. So I created my own data set to evaluate these systems with. And to do that, I collected images from Instagram using different gender hashtags as a ground truth. So given the nature of hashtags on Instagram, all of the genders were thus self-labeled by Instagram users. So if the image was labeled with something like hashtag man, I would assume that male would be the correct classification for that person. And of course, there are a number of ethical implications for collecting a data set this way using web scraping. And I do describe the ethical implications and trade-offs in the associated paper that was in the beginning of this talk. And also I can kind of click through so people can see on the recording links to the papers at the end. So let's look at findings from the first kind of computer vision pipeline, facial classification. So this table describes the correct classification rates for all 5 services, but I just want to highlight a couple of interesting findings here. So here we can see the average correct classifications for cis women, cis men, trans women, and trans men. And when I say correct classifications, I mean that the classification the model returned aligned with the hashtag that I used as ground truth. And so we can see here that for my data set, at least, it could differ from other data sets. Cis women were correctly classified on average the most often of all 4 genders. On the other hand, trans men were classified incorrectly the most often. We can see that different services may classify the same images drastically differently, like what happened with mine. So IBM service was nearly 17% more correct on trans women's images and clarifies, which was only 77.4% correct. Finally, we see that the size and economic power of the company didn't always lead to more accurate classifications. So Amazon's service classified trans men the worst of any service at only 61.7% correct in its classifications. And as you probably gleaned from the prior study and the table, non-binary genders couldn't be correctly classified because the only possible outputs here were male or female or some form of man and woman. So why does this matter? So as I described in the examples of the introduction of this talk, these systems actually can have real world consequences. So for example, computer vision could be used to bar trans people from specific social spaces like bathrooms. This was a hot button issue when I started doing this work, and it's actually just gotten worse in the United States instead of better. And it could also be used to restrict movement for trans people who already have issues, for example, with the TSA and border control. And we can also see from prior work that computer vision fails to validate passports for people with darker skin. So if trans people aren't included in data sets for facial recognition, that is also a problem. And finally, computer vision could be used to enact intentional violence by anti-trans governments, for example, to strictly enforce gender roles while criminalizing non-normative expressions. And these types of laws do exist across the globe. And so I didn't really speak on gender and object labeling much, but I go into more detail in the individual study. But this sometimes showed up in labels like returning attractive woman for an image. So both classifications and object labeling highlight that computer vision artifacts actually showcase specific value decisions about concepts like race and gender. So now that you understand kind of the state of identity in computer vision, or how it's been historically within the last 5 years kind of approached, let's talk more about how we got here. So implicit in these 2 studies that I just reviewed are that these values about identity are showing up in these artifacts. And so I also conducted work explicitly analyzing what artifacts can tell us about the values of their creators. Specifically, the values implicit in these artifacts are generally not human-centered, but focused on striving for this idea of universality and neutrality. And computer vision often propagates historical values that are present in colonialist perspectives with race and gender. So again, these are kind of the papers that I'll go over really briefly in this portion of the talk. But artifacts have politics, for those who are familiar with Langdon Winter. Bowker and Starr remind us that political and social agendas are often first presented as purely technical interventions. They say, as layers of classification system become enfolded into a working infrastructure, the original political intervention becomes more and more firmly entrenched. It becomes taken for granted. And so the current state of identity classifications in computer vision is a political decision, even if it is not necessarily intentional. And it's one that has become deeply embedded in development. So Bowker and Starr actually give us a method for understanding how infrastructures become taken for granted through this concept of infrastructural inversion, which is a research strategy that allows us to explore classification systems and how they evolve alongside scientific practice. And so I employed this technique to conduct a historical analysis of both the gendering of the body alongside the history of computer vision. And there are compelling parallels between studies of sexology and physiognomy, which are largely defunct at this point. But these kind of come together in approaches in modern computer vision, which posit the ability to classify gender, race, and even characteristics like personality and criminality from a person's face or their body. And this essentialization in computer vision communicates two things or two values historically present in colonialist views of identity. So one is that the face can always communicate these underlying quote unquote truths about our identities, including our personalities. And two, that whiteness is actually the main factor in defining identity, including gender identity. So ignoring kind of the histories of what gender looks like and what race looks like across the globe, and kind of defining it as a very Western-centric, particularly US-centric factor that we should be looking at. And to augment this historical analysis, I also did a content analysis of the broader values being operationalized in artifact documentation. And so in the paper, I do discuss 4 different value trade-offs, but I just want to focus on one that I think is relevant for the rest of the talk. So one of the major values that's communicated through dataset documentation for computer vision was this idea of universality. So that everything in the world could be captured in singular data sets correctly and discretely. And this was prioritized over the value of contextuality, so that data should be situated and shaped by a specific task, time, geographic locale, or perspective. But what would it mean to actually flip this and focus on contextuality over universality in computer vision and machine learning more broadly? Could it first of all, help us understand the context of a computer vision artifact, not only its intended use, but also its development? So as I've discussed, we can see that certain perspectives tend to be centered in the development of computer vision. Race and gender are generally represented in specific, often harmful ways that can harken back to colonialist histories and erase the most marginalized identities and portray that as a neutral decision. But how does that actually happen? Well, centering contextuality can help us here, and it leads me to the final section of this talk, how identity values are actually being embedded in these systems. Specifically, I'm going to examine how the context of work actually influences the outcomes of artifacts, causing identity to move from something that is open and nebulous to something that is closed and rigid. So in this final study, I'm going to show that the positionalities of traditional tech workers like engineers and researchers are embedded into computer vision much differently than those of data workers, the people who are conducting collection and annotation work on the data sets. And the positionalities of tech workers are generally privileged over that of data workers. And finally, as I mentioned, that in this process, identity is moving from something that is open to something that is rigid. And this is the main kind of crux of my dissertation work. It still says unpublished dissertation, but actually one study in my dissertation is being presented at CHI in a couple weeks. So if you'll be at CHI, I'm happy to talk more about this, and hopefully you'll be able to read the paper then. And so as I briefly showed earlier, at a super high level, the way that a model comes about, at least in an industrial context, is as follows. Requirements for identity in the system are defined. So the requirements basically determine what the model should do and therefore what data should be collected and how it should be annotated. Data workers are often hired to collect and annotate that data with identity information from these requirements. And then once all the data is annotated, it can be used to train and test the model. And once the data and model are finalized, there's this end product, and this end product represents a specific kind of identity. So I'm just going to walk through this with the gender classifier example to kind of ground it in reality. So at the requirements level, basically what gender should look like and what purpose it's going to serve in the end product is decided. And as we've already discussed, this is often male and female. Data is then collected for the two classes of male and female. And once the data is collected, each image is labeled with male and female. Sometimes this is like automatic. So when you're telling a data worker, go collect X number of images of men and X number of images of women, they kind of are already bucketed into those categories. Once the data is finished being annotated, the finalized data set is used to train and evaluate a model. And then this results in a classifier that can label new unseen images with male or female for different desired purposes. Like this might be marketing, this might be for personalization or security. And there's also a number of actors involved in this seemingly simple pipeline. So generally a product team of what I refer to as traditional tech workers, so like people who are employed as engineers, researchers at tech companies, are the ones who are responsible for determining the requirements, building the models, and training and testing the models. But data workers are usually outsourced and asked to collect and annotate data in alignment with requirements. There's been a lot of work on data worker labor in particular as something that's quite underpaid, undervalued, and very unstable. But we all look at something like gender and something like race in different ways. And so one way we can think about this is through the lens of positionality. Positionality describes the worldview a person develops as a result of this web of identities they hold. So the position each of us occupies in the world shapes our experiences and perspectives. For example, how people are treated by others for their perceived gender then impacts how they view the world. It also impacts their own relationship with gender. And given each individual has their own positionality, this way that they're viewing the world based on their identity, and computer vision is attempting to make predictions about human identity, how do these two types of identity intersect in the creation of computer vision? So as I've discussed already, certain perspectives are centered in the development of computer vision. And because race and gender are presented in specific ways, how is that happening? How is a worker's positionality influencing the outcome of these identity characteristics on computer vision? And so to understand this, I interviewed a total of 51 tech workers. So 24 workers were traditional tech workers. So they worked as engineers, researchers, project managers, those kinds of things. And then 27 were data workers. And these were divided among kind of 3 field sites. Traditional workers worked at tech companies ranging from kind of like tech giants that we're familiar with to smaller startup companies. And then I also established a relationship with this. It's a pseudonym for this company, Envision Data, which is an ethical data outsourcing company. And so I worked with them for over a year, conducting interviews, ethnographic observations with their C-level staff, their clients, and their data workers. And then finally, I interviewed 13 other data workers who performed freelance data work on Upwork. Envision Data would often outsource some of their data work to Upworkers, especially collection work. And so if they needed to collect data, for example, from certain regions that they didn't have workers based in, they would outsource this work on Upwork. And so I examined the way that kind of my 2 broad participant groups express positionality. Traditional tech workers generally defined what the scope of identity in computer vision products was, but it wasn't actually a straightforward task. These participants were pretty much entirely based in the global north. So they were mostly in the United States, in Canada, and Western Europe. And they had very strong individualistic values. So generally, they were largely focused on this notion of value trade-offs and negotiating constraints and differing perspectives with their colleagues and superiors. For example, tech workers would also describe how policy and internal politics would shape their decisions about identity concepts. So let me give kind of a concrete example about how tech workers discuss their positionality. So Elliot was a research scientist at a large tech company who said they're basically telling machine learning researchers if they're going to be in the business of making predictions about people and affecting things in the world, they need to adopt the strategy of understanding racial dynamics, as opposed to this is some fixed attribute of an individual we're going to control for after the fact. So here, Elliot is implicitly critiquing how they believe their more technical focused colleagues approach race in their work. And so they personally valued engaging with this idea of racial dynamics in terms of lived realities in politics, and believe that those in machine learning roles were approaching identity as a fixed attribute that they could solve a problem for. Also implicit in this example is that machine learning practitioners are taught to approach problems differently versus more social science researchers like Elliot. And many traditional workers discussed having these differing perspectives and their colleagues in different roles and how they kind of viewed the positionalities of their colleagues as an issue. And this also kind of begged the question about who gets to make final decisions about creating computer vision artifacts and what identity should look like. And here, Elliot is insinuating it's often the engineers who are viewing identity as a fixed attribute. On the other hand, data workers generally relied on their own experiences with people when they were conducting their work. So they often actually had difficulty with concepts that they were less familiar with. For example, data workers regularly described their own personal experiences with different types of people and also types of people they never really came into contact with. So certain racial groups and certain gender identities given their own geographic locales. And when data workers didn't see types of people often that they were asked to label, they actually had a harder time making decisions about them. So an example here is Jocko, who is based in Kenya, and he described kind of culturally contingent barriers to collecting face data, which is what he was asked to do. He basically described that there were these common religious concerns within his community that made people really wary and unwilling to give up their face data. And so as kind of a way to get around this, he would actually lie to participants about what the images would be used for, saying that they were for a personal project rather than a commercial project. And so he described how he basically made them believe him, because if he told them it was for an international commercial organization, they wouldn't believe him and they would have thought it was for quote unquote some kind of devil worshiping thing. And he described his own community as very primitive. And so Jocko expressed this positive perspective of technology and AI and described the culture in which he was situated in Kenya as primitive multiple times. As almost entirely based in the global south, participants in data work positions were generally constrained by poor economic conditions and expressed opinions colored by these Western-centric views of technological solutionism, which could have also been influenced by the fact that he was talking to me as somebody who was based in the West. But Jocko's story also provided interesting insights into barriers to accessing certain populations ethically. So even though this company Envision Data was focused on ethical data collection, they still struggled to actually do that, and didn't even know that this kind of thing was happening. And so Jocko himself was put in this position where he had to complete his task to maintain a positive professional profile on Upwork and to get paid. And so because of that, he felt it was necessary to lie to navigate cultural taboos that he was personally familiar with, but the data work company was not. And this actually starts to get into kind of the third major theme that I uncovered in this work, which was related to power between these two groups. So when you compare these two groups, this positional power started to emerge. So traditional tech workers didn't just have positions of economic power in comparison to data workers, but their positional approaches to computer vision were given more power and privilege than data workers, whose positionalities were often viewed as threatening to the quality of the data. So this is also something you see a lot in literature around debiasing or properly training annotators. And there were a number of instances in this work, but I'm also going to give kind of another example. So Gemma was another worker who was based in Kenya, and she described how she had difficulty differentiating between the ethnic groups that she was instructed to label. So she said, you can't differentiate between a Caucasian person and a Hispanic person. So it was sometimes a bit challenging. If I found an image I don't understand, I would just call the manager or supervisor to ask them about it. And if they can't get it, they forward it to the client. So here she's actually expressing this implicit disagreement that the categories that she was asked to label around ethnic identity were even meaningful at all to her. But she also wound up relaying all power to make those decisions to the client, the traditional worker who was employing her. So of course, those identities still wound up being embedded into the data set. Meanwhile, Lynn, who was a traditional worker, expressed this inherent distrust of cultural biases that data workers in particular in the global South bring to the data. So she said, I can tell you, having worked with overseas for so long, it's like whack-a-mole. As soon as you find a sense of cultural bias, you have to peel away the layers of the onion. So Lynn and other traditional tech workers acknowledge that traditional tech workers have their own perspectives and values, but they didn't discuss them as a bias in the same way they discussed it with the data workers. And they viewed the quote unquote bias of the data workers as something that had to be controlled, but not the same with the tech workers. And so let's return again to this development pipeline. So if you just look at it, it would look as though these different type of workers have near equal roles in developing computer vision. So traditional workers handle the scoping of the model, the scoping of the requirements, but data workers handle the data set. But this was actually not true in reality. Traditional tech workers actually controlled the entire pipeline, carefully curating how data workers collect and annotate data through documents, guidelines, and quality control. So the relationship between these two workers is being mediated through this pipeline, and the identity concepts are basically negotiated through these materials and documents. But generally, the tech workers were never coming into a room with the data workers to negotiate identity and confusions. And finally, let's return to the idea of identity moving from something open to something closed during this pipeline. So these two types of workers had very different power to define identity from something that's open to close. In the context of developing identity for computer vision, traditional workers' worlds were pretty much wide open. They were able to design how identity should look in computer vision from the start, and they were given the power to negotiate different positional perspectives with their fellow workers. Traditional workers would then put these worldviews of theirs into guidelines, instructing data workers how they should think about and deal with identity. And these guidelines act as a constraint to data worker positionality. So even though the data workers still had to access their own perspectives to do the annotation and collection work, referencing what's familiar or not familiar to them, they were still bound by this set of rules set forth by traditional workers. So the example of you have to go and label whether this person is Caucasian or Hispanic didn't make sense to the data worker given her own positionality, but she still had to do that work. And this all results in this extremely narrow worldview of identity at the end that's solidified into artifacts. So identity is moving from something that has these possibilities for expansive worldviews and maybe overlapping worldviews to generally something that's closed within a product. And given that traditional workers are the ones who are scoping identity, this actually indicates a need to focus less acutely in our research on data workers as a major source of bias and to focus more on the role of traditional workers. So it's pretty clear that these types of technologies are here to stay, but they also have a lot of assumptions built into them about some universal truth of identity. And many people have already critiqued this. The lens of positionality offers scrutiny to this worldview, and we should shift away from solely examining data workers and their outputs as sources of identity bias to also examining that of traditional workers. So we can understand how identity moves from something open to closed and maybe rethink these models of identity, resist current models of what it looks like, improve the way the processes, and include data workers in those processes, and maybe even dream up more radical visions of what identity can look like in these types of systems and who these systems are serving. And so as I conclude this talk, I also want to acknowledge the amazing colleagues who are involved in the work that I presented today. And I think we have time for some questions. Yes.
Very great work. This is fascinating stuff. Thank you so much, Morgan.
Thank you.
Yeah. I will open up the floor to everyone, but first.